Hi there, everybody. Well, we are going to start chapter 9, and we are going to see some more application of these trig functions that we've been working with since chapter 6. So the first part of this chapter is going to deal with polar coordinates. So the thing about polar coordinates and like why we use them, because that's what I was wondering when I first learned these two. Because I thought rectangular was totally fine. It's like, why I need two different systems. But the thing about polar coordinates, you actually use them quite a bit without even realizing it. Um, and you've been using them since you were a little kid. Like if you ask any toddler or any little kid where something is, like where's your ball? They usually point to it and tell you like where it is. So they've really just used a polar coordinate because polar coordinates they use distance and a direction to plot points and to graph curves. So when they point to something, they're telling you the direction, and if you can usually see it, then you kind of know the distance. It's also a little bit more efficient, so it makes some things easier to graph or work with, especially the equations. So like r equals 3, that graphs a circle of radius 3. So that's in polar coordinates versus trying to work with the same equation in rectangular, x squared plus y squared equals 9. You have two variables, they're both squared, so it's a tricky little function. All right, so let's kind of see what the differences are. So rectangular, you have the xy plane and the xy coordinate system, and then you've got your point here is the origin, and then points in the xy plane are listed out as x comma y. So you list x first and the y second. And so it gives you a rectangular grid on which to place your points and to plot your curves. Polar is a little bit different. So it still has a center like right there, and that is called the pole. And then straight out to the right is your polar axis. And then points can be listed anywhere on the coordinate system, but they're listed instead of x and y, they're listed out as r comma theta. So the r, it tells you the distance from the pole to where the point is. Or if you look at the graph itself, it tells you like which ring you're on. And then the theta tells you which direction you've just rotated from the polar axis. So going around that way, or if it's negative, you would rotate, clockwise. So that's the difference between the two systems. So example 1, let's go ahead and plot these polar coordinates out, and they can be either in degrees or they can be listed out in radians, either one. So what I usually do is I look at the angle first, so at least I kind of know where it is, and then I'll use the r to tell me exactly which ring I'm on. So 270 degrees will be straight down. And then 4, I'm on the fourth ring. So 1, 2, 3, 4. And that would be my first point. That would be point A. For B, pi over 6, 30 degrees. Be right there, and I'm on the first ring. This one, part C, you have 120 degrees. So that's going to be right here. But it has a -3. So if you remember from your trig class, when the r is negative, it's going to flip it around in the opposite direction. So basically it flips around 180 degrees. So normally we would be right there, but now it's going to flip and go down this way into quadrant 4. So 1, 2, 3. And there is point C. So now for D, they're both negative. So the -2 pi over 3 is going to rotate this way, so that's going to be over here. And the -2 on the r is going to flip it around back into quadrant 1. So that's how you plot them. And the thing about polar coordinates, are they unique? The answer would be No, because you can rotate in more than one direction to get you to the exact same point. You can also have a negative r that flips it around. So you can actually give multiple points that plot to the same exact location. So let's go ahead and try that out. So example 2, find 3 other polar coordinates that plot to the same position. So we'll do the first one, 5, 2 pi over 3. So what I usually do is I'll keep the r the same, and then I'll rotate in the opposite direction. So at 2 pi over 3, that's in quadrant 2. So I'm going to rotate around clockwise. So 2 pi over 3 would be here. So I'm going to rotate around this way. So that would actually be negative 4 pi over 3. And for the second one, let's make the r negative. So I want to land at 2 pi over 3. I want to land on this angle, but if I'm having a negative r, that means I've got to land at somewhere in the 4th quadrant. And I can rotate in either direction. In fact, that's how I'm going to get my next point. So let's go clockwise, or counterclockwise in the positive direction. So over to here. So that would be negative 5 comma 5 pi over 3. So then the third one, if I still had a negative r, I would just have to rotate this way, and then the negative r would flip it over into quadrant 2. So if I rotate in this direction to get to this angle, that would be a negative pi over 3. Okay, so that is a little intro to polar coordinates. In the next video, I'll continue, and we're going to be converting from one format to another. So stay tuned.